All right, so if we're talking about a vector, we have to have a starting point and a ending point. Let me change my size here. So if I have vector v, we can write it in component form. So like if I have 2, 5, that is vector v in component form. It has a starting point, and it can start anywhere because it just has to have direction and magnitude. So I can just start there. And the 2 is my x change, and my 5 is my y change, kind of like a point, not like slope. So that 2 says to go to the right 2, and the 5 says to go up 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. And so that would be the end point. So, I don't know where I lost my length here. So then I could direct that vector in the correct direction with the correct magnitude or length to represent vector v. Now if I wanted to do another one, let's change his color. Let's say I have vector w is going like 7, 1. I can start that vector anywhere. I can start him right here. And then the 7 would tell me my x change, y would be 1. So I would go over 7, 1, 2, 3, 4, 5, 6, 7, and up 1. And that would be my ending point, and the vector would be going in that direction because I had my starting point and my end point. If I wanted to add those two together, so if I wanted vector v plus vector w, I can do it a few different ways. We can put them end to end. So like the head of vector v, I could add on vector w, or I could just add their components. So like the 2 and the 7 that were the x values would become a 9, and the 5 and the 1 for the y values would become a 6. But the other thing you have to be able to do is represent it on a graph. So since I had vector v drawn already and vector w drawn already, I just need to put them together. So that was vector v in the black. And so if I have vector w added onto it, I'm going to start on vector v's head and draw vector w. So 1, 2, 3, 4, 5, 6, 7, 8, nope, 7, and up 1. That would be vector w put on the end of vector v, since I'm trying to add those together. Then what I can do is I can start from my original starting point of vector v all the way to the end of vector w, and that represents vector v plus vector w. We already knew what it was in numbers, but I want to show you that on that graph I get the same vector, because this is going over 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 1, 2, 3, 4, 5, 6. So that 9, 6 shows up in the graph as well. So then there are other things we need to do. Probably shouldn't have erased all of those.